Hello everyone, welcome to my channel. If you are new to this channel, please support the channel by subscribing and sharing these videos with friends. It will help us grow the channel and develop as many videos as we possibly can and support as many students as we possibly can. Now in this video I have this integral to work on. It's the integral of 1 over sine x times cos x dx. Now I invite you to try this one. How would we approach it? Well, there's a simple trick that we use here. Let me begin by capturing the integral. So we are dealing in this video with the integral of 1 all over sine x times cosine x dx. Now both sine and cosine are dividing, and therefore it is safe to assume that cosine is not equal to 0. And so if we square cosine, we also get an expression that is not equal to 0. Now the trick I'm going to use is divide by cosine squared in the numerator and in the denominator. Remember laws of simple algebraic division and multiplication. We can divide the numerator by some number, and as long as we do the same with the denominator, the fraction remains the same. Let me just remind you of what I'm trying to say here. I'm saying, suppose you have a fraction, let's say 3 over 5. If you divide in the numerator by some number, let's say 2, and you do the same in the denominator, this fraction does not change. So for example, I'm saying this is the same as 3 divided by 2 all over 5 divided by 2. Let's see what this becomes. The numerator is 3 over 2. The denominator is 5 over 2. And what does this mean? It means 3 over 2 divided by 5 over 2. And if you simplify this, you'll agree with me, 3 over 2 times 2 over 5. The 2's cancel, and what are we ending up with? Same fraction, 3 over 5. So what you do in the numerator, do the same in the denominator. The fraction does not change. So therefore, I'm saying we're going to say this is the same as the integral of 1 divided by cosine squared of x, and I'm going to do the same in the denominator. Sine x cosine x divided by cos squared of x. You'll understand shortly why I'm doing this. Now, in the numerator, notice you can actually rewrite this as follows. You're going to say this is the same as the integral of 1 all over cos squared of x. We're dividing that whole expression by sine x cos x divided by cos squared of x, and then we have dx. You'll agree with me that 1 cos cancels 1, and so in the numerator you still remain with the integral of 1 over cos squared of x. We're dividing all of this expression. Remember now here you have sine x all over cos x dx. Now what do we have in the numerator? Remember 1 over cosine is secant. So the numerator then is sec squared of x. Let me put these papers in order. So what we have now in the numerator is, in the numerator we now have sec squared of x, and we're saying divided by, in the denominator you know that sine over cosine is actually tangent of x. Now we have dx. Now we can use substitution here. As you can see, we're now going to let u be equal to tan x. And obviously you remember now, you should recall that du dx is actually equal to sec squared of x. Derivative of tangent of x with respect to x must be sec squared x. And multiply by dx both sides. Du is equal to sec squared x dx. Fantastic. Now I'm going to take this expression to replace that. Remember, sec squared dx is this one here. Let me rewrite that for you to see it clearly. So this integral is the same as the integral of 1 over tan x times sec squared x dx. Fantastic. Now notice this is du, and that's 1 over u. So this is the same as the integral of 1 over u du. And you know that this is just the natural log of u. And then we have to say plus c because this integral is an indefinite one. But what is u? Moving back, u, if we move back to page, actually it's the same page. If you move back here, you see that u is actually tan x. So this is the same as the natural log of the absolute value of tan x and then plus c. That is the final solution to this integral. I want to say something here, that I had to divide in the numerator and the denominator by cos squared, but if you decide to multiply in the numerator by cos squared, denominator by cos squared, it will take you to partial fractions, and then if you simplify whatever you get from there, it takes you back to this final solution as the natural log of the absolute value of tan x. And then we have to say plus c because the integral is an indefinite one. All right, I am going to stop here. Tell me what you think about this integral. What approach would you have taken to arrive at this solution? All right, your feedback remains critical. I'll see you in the next one.